Hey yo, what's up guys? BabyBear4812 coming at you one more time. Today we're doing problem number 24, which is swap nodes in pairs. It's actually my third time recording this video. I keep making the same damn mistake every time. But not this time, third time's a charm. The reason we're doing this question is because it's asked by Microsoft, Facebook, Amazon, Bloomberg, Adobe, Google, all the big guns. I think it's an appropriately rated medium question. I don't think it's too hard. It's similar to the reverse a linked list problem, so I think this is one you should really know, and I think it's intuitive. Essentially, if you haven't tried it yet, this one says that you're given a linked list and you want to swap every two adjacent nodes and return the head. You get a caveat saying you can't just move the values around. Okay, we actually got to shift the nodes around. I know you guys are clever and you just want to, move the numbers around. It's not going to work this time. All right. Just to give you an example, if we're given 1, 2, 3, 4 as a singly linked list, we want to return 2, 1, 4, 3, meaning that 2 and the 1 swap, the 4 and the 3 swap, and we want the 1 to point to this 4. Ultimately, okay? What I'm going to try to do in this video is I actually want to kind of code and whiteboard simultaneously. So as we're walking through the logic, we'll put the code down as we go. I think that approach lends itself well to this problem in particular. If you guys like it, if you dislike it, let me know in the comments down below, and I'm happy to adjust as we go moving forward. But I am curious to hear what you think about this approach. All right? So without further ado, I think with this problem, one logical way to start would actually be to start thinking about the edge cases first. Generally, we have three possible cases. We'll call them A, B, and C. A is none, so we're given 0 nodes. We're just given none, right? Second is we're given 1 node. And the third is we're given 2+ nodes. In 0 or 1 nodes, we can't do any swapping, all right? We can't do anything. So all we're gonna do is just return as it is. All the fun happens in this third case, and that's what we're gonna spend a majority of our time doing. So what I'll say is if we're not given a head, or if we're given a head, but we don't have a value after that, so not head.next, then what we wanna do is we just wanna return the head as it is. All right, now that the administrative stuff is out of the way, let's scrap this and let's get back to it. So for those of you familiar with the reverse a linked list problem, and if you're not, if I don't have a video up there yet, check my channel, but I should have one up there because I do want to go over it. It's a good utility function to know. We typically approach that problem with 3 pointers, okay? We'll set a previous pointer, a current pointer, which is where we start, and a next pointer, which I'll just call N. I usually denote it NXT for next, all right? The previous pointer we typically set to none, and what we want to do is we want to say, well, the current and the next one we're kind of going to swap, and the previous one trails along, and it's going to point to the next value we want it, and we want to sequentially kind of advance these pointers as we move along. Meaning that, in my opinion, the best way to think about this problem is this, is to say, first step is let's actually set up these pointers. So to do those, that'll be super straightforward. We'll just say previous is equal to none, cur is equal to head, next is equal to cur.next. One final thing that we may want to think about here as well. In the problem, it does say we want to return the new head, which is 2. Namely, it's the second, the second node from our original list, which we've now denoted next. So what I'll do is maybe I'll set a variable called new head is equal to next. Ultimately, I'm gonna return new head down here, okay? And we'll say this is where the magic happens, all right? Between these 2 spots. So usually when we're doing a reverse linked list problem, there are 2 components that we need to deal with. One is the swapping of the arrays, all right, or nodes, the actual swapping of the nodes. The second part to that, which subsequently comes right after, is rearranging the pointers to where we want them to be. What I mean by that is this. Currently our pointers are sitting here. In the next rendition of what I want to see, if I can get my pen out, I want to see a 2, and I want to see a 1 right here, and then I want to see 3 and 4. This isn't going to be our final answer, but it's the next step of what we want, all right? We want none. So if I swap these around as is, and let's say I do that successfully, well, what's going to happen is, see how this current is pointing at the 1? That current is still going to be here. And the next pointer is going to be here, and the P pointer is going to be here. So that's all wonky. We don't want that. So what we want to do after we swap the nodes around is move the pointers to where we want them to be. So this is all going to happen in a while loop, okay? And we'll kind of define what the conditions of that while loop are. But for now, let's just for a placeholder, we'll have some while loop. We'll say while true. We're going to want to do 2 things. The first is we're going to swap nodes. The second is we're going to want to advance pointers. If you can get in your head that we're swimming in two parallel lanes and these are two distinct tasks, if you can figure out how to swap nodes properly, then advance pointers properly, you win. You go home happy, you get the job, we all party, all right? Everyone eats. So let's tackle these two problems separately as we walk through them, and we'll write the code in as we go. First things first, let's compare, oops, there we go. Let's compare what we have, namely this is what we have, to what we want, which is this. We want 1 to be pointing to 3. Right now, 1 is pointing to 2. I want to sever this relationship and make it point to 3. Okay? I want to sever this relationship and make 1, sever it and make 1 point to 3. All right? So I'm going to do that by saying cur.next is no longer equal to 2. It's going to equal to next, right? This next, dot next. All right? I'm going to say that cur.next is now going to equal next, dot next. We want to take this node's next value and have current point to it, all right? We want this to point over here. That's the first step. The second step is, see how this 2 is pointing at the 3? We don't want that, we want the 2 to point at 1. So we want to cut this relationship, all right? Off with the head and make it point back this way. We want this node, which is right now the next node, this n, we want next to point to cur. If we want next to point to cur, we want to say next.next is equal to cur. We have now successfully we've severed these relationships and we're making this point to here. Aesthetically, all that I've done now is I've moved these around, but really there's no difference now between these two steps. Previous is still here, and for those of you familiar with the reversal linked list problem, I know you're yelling at me right now, you haven't moved the previous one, we'll get there, okay? And we'll do that in the next step because I think it'll come a bit more logical when you kind of have to error check and debug what you're doing. So we're almost done here. Oh, sorry. We're almost done here. There will be some sort of other, what about prev? Okay, we'll address that in a second, I promise. Now, we actually want to advance the pointers. How do we want to advance the pointers? Well, let's think about this. Let's go to a new color. Let's call our color blue, all right? This is where our pointers are right now. However, this is not where we want our pointers. We want our current pointer to be here now because we want to swap the 3 and the 4. So we want the cur here, we want the next here, and by logical extension, we want previous to point here. So how do we make that happen? Well, let's think about how we're going to move each of them. It looks like, previous just needs to go to where current is right now. So that's easy enough. Previous is equal to where current is. Fine. We now no longer have to deal with this. Previous is no longer here. We just put it right here where cur was, and we're happy there. That's where we want it, okay? What about cur? Well, it looks like cur is just going to move up by 1 spot, right? So we want it from here. We want to get it there. So maybe we can just say cur is equal to cur.next. All right, easy enough. Where do we want next, though? So, cur is gone. Now we deal finally with our next pointer. Well, this one's got to take a few jumps. This one has got to go to wherever our cur is now, which is right here, plus 1 step. So wherever cur is right now, plus 1 step will get us to next, to where we want next to be. So that means I just want to say that next is equal to cur dot next, right? So this cur here and this cur here are now different in 2 separate steps, okay? Because of how I walk through them. Now all of our pointers are where we want them to be, and we are ready to start doing our swapping. Again, some of you are yelling at me. If you know where this problem is going, this might cause us a bit of an issue, all right? Be a bit of a sore point if we're kind of out of bounds. I'll address it, I promise, all right? So now that we're here, let's take one more stab now at what we want to do. We want our next step, or you know what? Let me draw out the final step in black again, just so I'm kind of consistent here. We want 2, 1. 4 and 3 want to be swapped, okay? And then we're going to none. All right, cool. So, well, if that's the case, we're gonna want to swap these. And so what's gonna happen when we do our swaps is we kind of end up killing, where is it? We end up killing these relationships as we did before. So current, this 4, it's gonna point to none. Excuse me, what was it here? Right here. I want to kill this one and make 3 point to none. Okay, that's what we want. You know, that's what we got here. Fine, we're happy. We're going to want to kill this. We don't want the 4 to point to none. We want to point it to 3. And okay, that's what we want. We're happy. So, you know, this is how we want things to look. But here's the problem. See this one? See this one over here? This one is still pointing to the 3. Meaning that, as things stand, this actually doesn't exist. This is what it looks like right now. And that's no bueno. Okay? So, how do we actually deal with this? The reason we didn't have to worry about this before is when we started out, P was none. But if P isn't none, we gotta make these connections right. Okay, this isn't cool. We can't have this pointing to the 3 and the 4 pointing to the 3 because then this link over here is missing. So what I'm gonna have to say here is, what about preview? Well, if there is a previous node, then we gotta do something about it. So what's that something we gotta do? Well, I wanna take this connection and I actually want to point it to the 4, right? I want the one to point, I hope this doesn't get confusing. I want it to point to the 4 because I want 1 to point to 4. So after all this, I want to say that prev, right? And let's think about this. Maybe I'll do this here. We swap these, right? So that means next is now here and current is now here. That means that I want my prev.next, right? This is still P. So I want prev.next to equal next, all right? And that's the trick here. I want prev.next to equal next. Oops, English. Prev.next to equal next. So I hope that makes sense, guys. Again, if it doesn't, pause the video, rewind it, and try to rewatch it again. If it really still doesn't make sense, drop a question in the comments down below. I'm happy to address it. Now, we're good. So we have the list exactly how we want it to be. However, we don't know that we're done yet because we still need to move our pointers around. So let's think about how our pointers are going to move now. This is where they stand right now. Technically speaking, let me bust out one more color. I was going to ask you guys what your favorite color is, but obviously you can't really answer me. Let's do orange. Hope you like orange. You know, if this list kind of would have kept going, we would have had to move the cur up here, and previous would have been here, and then the next would have been up here. So the problem is that, you know, we're going to go through these steps because that's where we're advancing our pointers. Problem is this. This line over here, it says next is equal to cur.next. Well, what if cur is none? Right? If cur is none, then saying cur.next will give us an error. So the only time we can really do this is if cur actually exists. So if cur actually exists, if it's not none, then we can move that next pointer up. And then we end up, you know, so this pointer is never actually going to make it here because current is not defined. Since current, or rather it's got a none value. Now that current has a none value, when we get to the top here, we're saying, okay, we want to break out. So this is kind of no longer true where we would kind of define, okay, when cur isn't a thing anymore, and also cur and when next isn't a thing either. Because potentially we can get to the point where maybe we had an odd length here, maybe we had just one more value over here, you know, let's say we had another node 6 and then that pointed 1 over, then next wouldn't be defined. So that way the 6, we wouldn't want to like swap it with anything. So that's why I'm saying cur and next here and not just next. These two are no longer defined, especially cur is not defined. So we're done with this loop. We go ahead, we return our new head. And if I got it all right, there we go. So I'm going to submit this, make sure that it works for all cases. And there we go, 95% memory usage. Well, we couldn't do any better on memory. But regardless, linear solution, linear time, constant space. Again, guys, let me know if you like this format of doing the whiteboarding and the coding side by side. Again, I think this approach lent itself well to this problem in particular. Would have been a lot of drawing and a lot of repointing to then go to the code. It wouldn't have been fun. Let me know what you think either way. Let me know how else I can help you guys prepare for your software engineering interviews, and I'll see you guys in the next video. Peace.